So here's the next question, question number 5, 1.2. The question is very simple. Just to place some statements in this question, nothing else. Check whether 6 power n can end with digit 0 for any natural number n. We have to check. That whether 6 power n is any positive integer, 6 power n can end with the digit 0 or not. So there is an fact that if any number end with digit 0, it should be divisible by 10. For example, whatever number you take, suppose 320 I am taking this number. So as you can see, the unit digit is 0. That means this number is definitely or obviously divisible by 10. It is truth. Means any number when it is divisible by 10, that means it will be having a unit as a 0, or we can say corresponding, if any number ends with digit 0, then it must be divisible by 10. So if it is divisible by 10, that means what are the factor of 10? It is 2 and 5. That means that number should also be divisible by 2 and 5. If it is not divisible by 2 and 5, that means there is no 10 is missing, and if 10 is missing, that means the number is not ending with the 0, it may be ending with some other number. So let us start with a statement. So we know that the solution, we write a statement. We know that, what we know? We know that if any number ends with digit 0, if any numbers and it is 0, it should be divisible by 10, or it will also divisible by 2 and 5, क्योंकि as 10 is equal to 2 and 5. Therefore, let us see the prime factorization of 6 to the power n. The prime factorization of 6 to the power n is what? 2 into 3 to the power n. Can we see 5 in the factorization of 6 to the power n? No. That means 5 is missing from here. So we can write here that hence 5. So hence we can write one more statement. Hence 5 is not a factor of 6 to the power n for any value of 6 to the power n, or for any value of n, 6 to the power n will not be divisible by 5. So if it is not divisible of 5, what can you conclude? That this number cannot be end with the 0. Therefore we can write the final conclusionary line. Therefore 6 to the power n cannot end with the digit 0, with the digit 0 for n natural number n. I hope it is definitely clear everyone. It's very simple. Let me revise it up. So what we actually have done here, we just have written few statements. What statement is that? If any numbers end with digit 0, if any numbers end with digit 0, that means it one factor should be 10. For example, let me write suppose 260. So you can see these numbers include 0. So whatever, you can take a large number also. Let us take 38420. So I have taken 5 digit numbers. This number also end with digit 0. That means if the numbers end with digit 0, that it must be, or it must have to divide by divisible by 10. Then only I can say that this number can end with digit 0. That is why in this question also it is said that it is asked you that whether you have to confirm that whether 60 power n can be able to end with digit 0 or not. So we have done with a statement. We know that if any numbers end with digit 0, that means it should be divisible by 10, obviously. If it is divisible by 10, so or it will also divisible by 2 and 5. Because why we are saying that it should be divisible by 2 and 5? Because we know the factors of 10 is what? 2 and 5. That means the number should be divisible equally by 2 and 5 also. I hope it is clear. So then we have found that the prime factorization of 60 power n is what? 2 into 3 power n. Here, hence 5 is not a factors of 60 power n. Here we cannot see 5 here. 5 is missing from the factors. If 5 is missing from the factor, that means the number is not divisible by 10. And if the number is not divisible by 10, we can say that number cannot be end with digit 0. Therefore, we can write for any value of n, whatever value you take here, 6n will not be divisible by 5. Obviously, 6n cannot be divisible by 5. Therefore, 6n cannot end with the digit 0 for any natural number. This is the final conclusion statement that we have put over here. I hope it is very clear to everyone. Thank you.